Okay, so let's define the term primary productivity. So let's scroll back for a second. Let's have a look at this picture here. This could be quite scary when we look at it, but actually what we're just looking at here is a food chain. And I highly recommend that you take a quick look at a diagram like this, but then go to the questions. So if we look at it quickly, we've got, this is the overall amount of sunlight reaching the earth. And this here is the amount of the energy that is absorbed by the plants. Remember, some of it is lost, hits other parts of the ground, or it goes straight through the leaves, or it's reflected off. So we end up with just this here. This is the gross primary productivity of the plants, 87,402. And then some of the plants get eaten by primary consumers, and some of the plants they die and be decomposed, and then some of the energy is lost to respiration. In fact, quite a lot, right? Because remember, only 10% is ever passed on to the next level in the food chain. So that's what we've got there. So now, without like sort of getting too caught up in it, let's scroll on down. Actually, I'm going to write these numbers to take them with us before we go. So we've got this amount here, 1.7 times 10 to the 6. And here we've got, we said GPP is 87402. Sorry, I'm going off the screen there. And respiration is 50177. Okay, so let's scroll down. So let's look at this question first. Define the term net primary productivity. So net tells us that it is after we've subtracted the losses to respiration. Primary tells us that it's in a plant. So it's productivity, so like gain in energy, or in biomass. We can measure it in either. So it could be joules or it could be grams. And then what's really important is you put per unit area. So this could be meters squared, centimeters squared, kilometers squared, per time. So this could be per year, per second, per week. So it could be that it gains 3 grams of biomass per kilometer squared per week. Define the term, and then we need to say as well that we have the net productivity is after accounting for losses to respiration. Okay, remember, so this includes losses to respiration. It's paid the tax. Okay, one thing you can't do here, you could write out the equation of that net primary productivity equals gross primary productivity minus R, but you can't just write out the symbols because you're not telling the examiner enough information. So if you just write that, that's not okay. You need to say what these are. Gross secondary productivity then. So again, we've got gain in energy or biomass per unit area per unit time. But in this case then, not accounting for losses to respiration. And in here, we're looking at secondary. So this is in an animal or a primary consumer. So you need to say something about that. Calculate the efficiency of conversion of total insulation to MPP in figure 5. So for this question, you need to, yes, so for this question, in the mark scheme, you will notice that it gives you credit for either saying 1.7 or it will give you credit for 7.1, okay? Because when we look back up at this, basically this is a flaw of the exam rather than something you need to worry about. But when we look up at this this diagram here, see it says total insolation of sunlight, but really they wanted to ask you about this 1.7 times 10 to the 6, but they put the question in terms of total insolation of sunlight, which means they have to accept 7.1 times 10 to the 6. So either of those can be okay to talk about. So we have got then, we need to know, now it's asking for MPP, okay? And so the MPP is gross primary productivity minus R. And we know the gross primary productivity was 87402 divided by 501, oh, I'm sorry, minus 50177. And that gives us 37225. Okay, and so then we divide this by the amount of the insulation. So either it is 1,700,000, or you divided it by 7,100,000. Okay, which this one is probably the more likely one that you use, since it did ask for total insulation. If you did this one, you ended up with 0.52%. Or actually you ended up with like 0.0052, but you multiply it by 100, so it's 0.52%. If you do this one and you divide that, you end up with 0.022. You multiply it by 100 to get your percentage, and it's 22% efficient. For this question, if you got as far as realizing that this or this, so this is 37225 as well, so either this or this, I will give you the mark for this, okay? Because I think it got confusing that they would accept either one of these. And so, yeah, I want to give you the mark. It's still a very hard question. I don't expect that many of you got this, but for those of you that did, well done. So I've just cleaned the screen there. Why is not all sunlight emitted? So this was actually in the PowerPoint. So you have a leaf. Some of the sunlight will pass straight through. So our light just goes straight through the leaf. Some of the sunlight will bounce back out. Some of the sunlight is not the right wavelength, right? So for the plant to absorb it, there I've drawn the yellow rays, but if the rays are the wrong color, not used by photosynthesis, so for example green, the plant reflects that, that's why it's a green color, then that light will also not be used. Some of the sunlight passes by the plant, and so it hits the ground instead. So that's at least 4 right there. I mean, there are many other things that you can say. I mean, you can talk about it being bounced off by clouds. You could talk about it being reflected by Earth's surface. So maybe there's some ice and snow, and then the light comes in and is reflected. But even around the leaf here, you can have 4 different reasons.